Okay, just a couple more of these. One more to make sure we have the idea, and then one to make sure we really have the idea. Alright, so here we have the square root of 8 over the square root of y cubed. Now again, you really, the best thing to do here is to make sure that these are fully simplified when you start rationalizing. So I always like to simplify first. Looking at this square root of 8, I know that there's a perfect square inside of it. I know that 4 times 2 is actually 8. So if I change those both into square roots, the square root of 4 is 2, and we can't do anything with this. So that means that I really have 2 square roots of 2. That's the same thing as saying the square root of 8, just more simplified. On bottom, here we have the square root of y cubed. Well, do you remember when we were working with these and we said, okay, this number inside here, of course, because it's a square root, is a 2. It's just not written. But when we're dealing with the letters, you remember us just dividing and saying 2 will go into 3 one whole time with 1 left over. So that would simplify into y times the square root of y. Now we can start rationalizing our denominator to finish simplifying it. So let's look at what we want and try and get there. We would really like this to be perfect. So since it's a square root, we want it to be a perfect square underneath there so that it would cancel out. So we have to decide, what do we multiply by to make that happen? Well, we'd have to multiply by the square root of y. And again, we can do that as long as we do top and bottom, so we're multiplying by 1. So now 2 times the square root of 2 times the square root of y would be 2 square roots of 2y. And now we can finish simplifying. On top here, there's not much we can do with that. 2 square roots of 2y. But on bottom we have y times, and here the square root and the square undo each other, which is what they should, to give us just a y. So now, perfectly simplified, this would be 2 square roots of 2y over y squared. That is the best way to write that answer. Okay, now let's see if you've really got the idea. Remember, we don't want an irrational number in our denominator, so we have to figure out something that we can multiply by so that we'll get rid of that. Now, because we're working with the fifth root here, what does this power have to be in order for them to cancel out? It has to be a fifth power. Now, we have to decide what are we going to multiply by to make that happen. Well, we would have to multiply by the fifth root again. They have to be the same in order to multiply them. So 3 to the first power times 3 to what power would give us 3 to the fifth power? That would have to be 3 to the fourth. Because remember, when you multiply like bases, you add the exponents. So we have to do the same exact thing to the top to keep everything nice and balanced. And remember, also, so you're multiplying by 1. That's a much better way of putting it. So here on top we have 5 times the fifth root of 3 to the fourth power is actually 81. So we can go ahead and write that out. Okay, so now let me come down here to finish simplifying. So we have 5 times the fifth root of 81 over, now on bottom here, our fifth root and our fifth power will cancel each other out, and we're just left with a 3. So this is actually the fully simplified version.